So page 4 was the half a symmetric one, and then we had a symmetric one. So page 5, this is the asymmetric, where starting and ending at different heights. There were a lot of ways to solve this one. You were given more than I needed to give you. So the projectile was launched from the ground with an initial y velocity. V0y is 50. After 3.06 seconds, the projectile's y velocity is 20 meters per second. During this time period, the projectile has traveled a horizontal distance of 50 meters. What's the projectile's height at the moment when its y velocity is 20 meters per second? So there's what I did. Let me think through it this way. So I don't know why I have extra stuff here. Actually, yeah. So this is velocity. V or V0. V0. And theta. I could also have V, but let me just V0 and theta in there. The x dimension stuff, I'll just write d, r, t. And with an understanding that r is the x velocity and d is the x displacement. But it's nice and simple looking this way. And then in the y dimension, we've got v0y, vy, acceleration, y displacement, and time. So you're given a lot. You're given v0y, and you're given vy, and you know a in the y dimension is negative 9.8. And we're looking for the height at the moment, at this moment here. So really, we're looking for delta y. Delta y is going to give us, how far it moves in the y dimension. So if I have the initial velocity, final velocity, acceleration, and I'm looking for displacement, this is a useful formula. So I can plug in 20 for Vy, 50 for V0y, negative 9.8 for A, and then solve for delta y. If you did that and you got the wrong answers, you should have squared this, subtracted this squared, and then whatever you get there, you divide that by 2 and then divide it by negative 9.8, and you should get 107 meters or something close to 107 meters. So this is 107. Oh, and time. I'm given time too. Wow, you're just given all sorts of things. So there is probably another way to do this. Yeah, so given that, you could have used delta y equals v0t plus 1/2 at squared. So just lots of ways to solve this. Now, initial speed, I'm looking for this, not the initial x velocity or y velocity. I need this. So let me clarify what I mean by that. Here's theta. I want this. And what I have right now is v0y, which is 50 meters per second, but I need, in order to get that, I need this other component. So I need this rate. Ooh, I have something else. I forgot to write it down earlier. I have 50 meters. That's the distance it travels in the x dimension. So I can get this rate. So here's what I did. Distance equals rate times time. The rate is 16.3 meters per second. That is the x velocity. That's the rate in the x dimension. So if I want this, the speed, now I can get it using Pythagorean theorem. I square this and I square this and I add them together and I take the square root. So that is 52.6. And then what's the angle at which it was launched? Well, I can find the angle. The tangent of this angle is SOHCAHTOA, opposite over adjacent, 50 over 16.3. So therefore, the inverse tangent of 50 over 16.3 is theta, and that gave me 71.9. A lot of people wanted to say north or south or something like this, but this was just the angle relative to horizontal. It's above horizontal, technically. You're not going to shoot it very far, shooting it below horizontal from the ground. And